Today, we are going to delve into some of the things we did in the previous class. But today, we are going to see them in action. We're going to see how we can implement those things. And then, after implementation, we would see how they are done. So, um, for lack of a better word, let's begin. Let's begin immediately in delving into them. Today, we're going to see how we can write or how we can practicalize the stack and the queue. So over here, I have stack, and then over there, I have my queue. And we are saying that for me to do a stack, I need to first have a global array. And the global array I'm going to call stack size. Now, after I create a global array, I'm going to create a method which is going to take the item I'm going to push. And then I'm going to take another method which is going to take the item in which I'm going to pop into my array. For the queue, I'll also create a I'll also create a global variable for it. I'm going to enqueue it and I'm going to dequeue it. Enqueue, remember, is removes an item from the front of the queue. Dequeue means enqueue, sorry, is me adding at the rear, and dequeue means I'm removing from the what? The front. Now, very important things in which we should realize. Per our last lesson, we learned together what is a stack, what is a queue. And we said that sorry, we are presented with an image like this, where I can have this image showing up for me. In this image, we can see that if I want to push something, it means I'm putting the item at the back end like this. And with a stack, if you want to remove two, you are removing from the back like this. We discussed this last week. So this is the structure of a stack. Everything comes in from one position and goes out from one position, which means that at the end of the day, if you are the first one who comes in, you are definitely going to be the last one who is what? Out. Now we have to implement this using code. How will we implement this using code? So let's see how we would implement a stack using code. So over here, I have my I have my VS Code opened up. And in my VS Code, I'm going to open a new application. I'm going to call it stack.cpp, which stands for C++ file. And then in here, I'm going to write my C++ code to implement what I have just said I want to implement. Of course, if it is C++, then it means I need to include IO stream, and because I am going to have a size for my stack, which is 5, I'm going to preprocessor define that whenever you see the word size, it should be for the number 5. So I've indicated the size of my stack. When we say the size of the stack, we are saying how many items can the stack take. In my case, the stack can take 5 items. Are we clear on that? So that is technically that is the size of the array. That is the size length of the array. And remember, we have done the size of the array too. So in here, I'm going to also go on and using namespace std. So I'm using the namespace, which is what? Standard. Now, in here, I'm going to start writing my code. Remember, I have int main into brackets, curly brackets, and here I'm going to return 0. Now, at the top here, I said that I'm going to create a global array so that all the functions can have access to it because our data is 1. You understand? The queue, the stack is 1. So at the top here, I'm going to create my global array, and it is going to be an integer. It is going to be called stack. And then the size of the stack is what I have defined at the top as what? Size, which is what? 5. And then in here, I'm also going to say that top should be equal to -1. Yes. So the topmost position should be equal to -1. Perfect. Now, I'm going to write my first function. My first function is going to define what will happen if someone does a push. So I'm going to say void push into brackets int value. So technically what I have done over here is that I've said if someone makes a push, I would put in the value of the push. For example, if I want to put in, so over here per our diagram, I want to put in A, the value for A. All I will say is that my A is, let's say, 10. So push into bracket 10. And this would be added to my what? Stack. Now, to the person using it, all he wants to do is a push. And he's pushing what? 10. But what will happen when I tell the computer to go and push in 10? First of all, I will have to check that am I at the top of my array? And it is very important I know if I am at the top of my array. Why is it important I know if I'm at the top of my array? Because we are saying that if we have a stack, the topmost item is where you put the next thing. So when I'm asked to put something into my stack, I need to know where the top is. Because it is at the top that I will put the item in which I what? Have. So I first have to determine where am I? Am I at the top of the array? Remember, the top could be 0. The top could be location. The top could be location 0 or location 1. In this case, the top here, as you can see from the diagram, is C. But when we come over here, the top is now what? B. So me knowing the top is very important when it comes to a stack because the item, I'll put it on top of the what? The top. So the first thing I will do is I will determine if the top is equal to the size of the array in which I called size minus what? 1. So if the top is the size of the array minus 1, then I'll tell the user that you have reached a stack overflow. Hence, I should return. That means that whatever I'm doing in the function, I should what? Stop. Because if I have reached the top of my array, the very, very top, in this case, we said we are putting 5 things in. So if I have 5 things in, anything in which I put on top of that is an overflow. It's an overflow. It means that I've gotten here and now I'm spilling over. It's an overflow. Since I want to prevent an overflow, the moment I get to the very top of my array, I need to what? Tell you that, hey, you can't add anything anymore. You have to pop it out before you can add something and continue. So back in here, if this is not the case, then I'm going to tell the user that the stack should be equal to plus plus top. And this should be equal to the value the person is entering. And we should tell you that the item in which you are entering has been pushed into stack. Now, let's look at this code very critically. We are saying that the top is -1. We have taken a figure in which is so arbitrarily small that it is impossible to be that. Because remember, your array starts counting at 0. So we can't say 0 is the smallest because something could be at 0. So if we say it is -1, then it means that is the smallest figure possible in our environment that it can never be. First of all, I'll check if you have reached the top. You have not reached the top. So if you have reached the top, because of this return, you will never get here. When the code gets here, everything will stop. Now, if I don't enter here, I'll never get to return. Hence, I can continue my program. If I continue my program, I'll come here. We said the stack has a size of 5. That means that my array has 0, 1, 2, 3, 4 spaces for you to enter something in. Over here, I'm telling the computer that go to the location top +1. Top is -1. -1 + 1 would give me what? 0. That means that in this application here, I'm telling you, go and put the item you put here in location what? 0. Remember, I am using a ++ top. That is what we call a pre-processed operator. That is, I will do the increment before I act on it. If I wrote it like this, top ++, if I wrote it like this, that means that I am going to show -1 before I what? Increase. But in the other way around, I'm saying that increase it by 1, then what? Show. Remember, this also means that top will be increased by 1, and then now the value of top would be what? 1. It would be 0. That means that the next time you come here, I'll be putting an item in location what? 1. Then the next time it will be location 2. Then the next time it will be location 3. The next time it will be location 4. By the time it gets to location 5, over here, the top will be 5. The size of the top will be 4, sorry. The size of the array is 5. 5 minus 1 is 4. Since 4 and 4 are the same, it means I've reached the what? Top. I can't go again. So my program will stop and will never allow me to enter anything above of what? 4. With that in mind, this code here does the push for me. I've executed the push. Now I have to execute the pop. Pop means I'm removing, and I'm removing from the top. So in here, I'll create another array. I'm going to say it's going to, another function, sorry. I'm going to say it's going to be what? Void. It's going to be called display into bracket that. And then in here, I'm going to say if into bracket top is equal to -1, then we are going to tell the user that your stack is what? Empty. Which makes sense. If it is -1, it means he hasn't even put in something for it to go towards 0. Hence, we know it is empty. That's why we chose -1 as our top. So you realize that someone will just come into your application, he hasn't put anything inside the stack, but he wants to remove. Then you tell him, oh, there is nothing there. So you can't remove anything. And the moment we tell you you can't remove anything, we have to return so that none of the code that is in the function will continue to run. After that, I'm going to say count, so cout, stack, oh, sorry. So cout. Then in here, I'm going to say the stack top minus. Pop from stack slash. Fantastic. So in this case, I have just removed the item from the what? The top. Now remember, this means that I would show you what is there, then I would remove. You can see this is not minus top. So I'm not deducting before I show you. I'm showing you that this is the item that is there. Now it is no more the what? The top. The top position is no more that. What I have done typically in that section is I'm telling you that over here, what you have there is C. Then I go on to tell you that the top is no more C, but it is what? D. That statement I made in English is me putting a symbol over here and showing you what is inside that location in the array. So here, if it is 0, it is showing, if it is 1, sorry, it is showing you that at this location here, what is there is what? 1. Then I will subtract 1 from the 1, making it 0. So it means that now the top is what? 0. So that the next time you put an item, it will go to location what? 1. So I'm done with the pop. Now I have to display the items in my array. How will I display the items in my array? So void display. If the top of my array is equal to -1, then I should tell you that the stack is empty. So the code I have over here, not to waste my time. Oh, sorry. Just not to waste my time. I'll do this code here and put it over here. Then I'm going to say cout the stack elements. So for int I being equal to the top, I being less than, I being greater than 0, I minus. Because remember, when you are displaying the content of a stack, you display from the top to the bottom. And then in here, all I have to do is say cout the stack item into square bracket I. And then I'll do this and give a space here so that they are listed in a list for me. Now, when I am done with the for loop, I'll just say cout, go to a new line. Over the weekend, I formatted my PC, so I'm screwed. So let's see. Over here, I would say push 10, push 20, push 30, display. Pop. And you can see that when I say pop, I don't have to put a value there because pop means remove the one at the top. Oh, display. And then pop. So let me go up to the top here. Let me see. Oh, I called it display 2 here. It's supposed to be pop. Perfect. So I have this. So after I pop, I'm going to do what? Display again. So it means that I will have 10, 20, 30. It will show 30, 20, 10. Because remember, the top is at the last end. When I pop it, it means 30 will have to go away to show 20 and what? 10. Let's run it and see. So over here, I have what? 10 pushed into the stack. 20 has been pushed into the stack. 30 has been pushed into the stack. The elements of the array are 30, 20, and 10, but it didn't come out like that. So let's see what is going on over here. Let's see what is going on. Because it did push the 10. Okay? It did push the 20. It popped 0 from the stack. So it shouldn't have popped 0 from the stack. So let's see why we have it popping 0 from the stack. So let's see. Let's come back to the code. Make sure everything is okay. Let's clear here. Let me push in 10 and then display what I have done. And then I'll push in 20 and then display what I have done to in addition. So let's see. In unknown escape, okay, there's an error over here. Unknown escape this in push. Okay, let's see. Okay, it's N, not that. And you said push into what? So let's run it again. Okay, let me clear the screen. So CLS, let's run it one more time. So extra warning, okay, this is a warning, so it doesn't matter. So 10. So, but here it is showing me that the elements in it is 0. And I push in 20, so it is showing me the elements is 20 and 0. So there's something wrong with how I am doing the push. So let's see if I've made a mistake over there. So here I'm saying push int value is over here. I'm saying that the top over here should be equal to the size minus 1. This is fine. Over here, my display overflow is working. But here, oh yes, it is because of this one here. The top plus plus, the example I was doing. It's not supposed to be there. So let's start it again. So 10 is pushed into the stack. 20 is pushed into the stack. Fine, that's great. Okay. Now let's come to the display because I think I'm having a problem with my display. Minus minus, top is equal to minus 1. See, okay. So over here, I've made a mistake here. It should be I is equal to 0 because 0 is part because the indexes start from 0. So if I do it greater than it doesn't count 0. So now if I run it, my code should be okay. So I push in 10. It tells me that my elements are 10. I push in 20. It tells me my elements are 20 and what? 10. It's working perfect. So now let's do what we did in the beginning where I pushed in 10. I pushed in 20. And I pushed in 30. And then I displayed. Then I came to what? Pop. Pop. And then when I'm done popping, I came here to what? Display. So when I run this code, I have 10 has been pushed, this 20 has been pushed, 30 has been pushed. What is my stack? It is 30, 20, 10, which is how it's supposed to be. Then over here, I'm going to pop out what? 30. So now it is going to be 20 and what? 10. Remember, your exam, I can tell you to write all of this code. Sharp. Sharp. And I expect you to write it from beginning to the end. For me. You watch your code on machine so that. You want how to write a code. You want to write it. Well, why are you writing it? I'll just send it to your class group. And we control it. It will time on the bed on a cast time in the class. Oh, wow, but 16 minutes late. Can we go? We should go over. We should go over. Oh my God. I recorded the class. When I'm done, I'll send you the recording. Let's go from this to us doing a queue where we have the first in, first out scenario. So this is for when I'm doing a stack. Now I'm going to do a queue. For the queue, I'm going to say the queue size is also equal to 5. And here I'm going to say the front is -1. And also the rear, that is the back, is also equal to minus what? 1. Very important. Why am I doing both the front and the back when it comes to a queue? Because remember, in a queue, we are saying that you enter from one end and you go out from other end. So I need to know where the last person is and where the person in the front is. Did you understand? Unlike the stacking, which everything is in one location. Yes. So this would help me to know where the front person is and where the legs person is. Now, if you want to enqueue, so here I'll say void enqueue. That is, you are being added onto the queue. I would say int value so that I know what value I am adding to the word queue. Then I'll say if the rear of the queue is equal to the size of the queue minus 1, then I will tell you that the queue is full. So we can't take anybody else. Sometimes when you go to a hospital, you realize that they say the doctor is supposed to see 60 patients or 70 patients a day. Of course, it is not natural. They're supposed to be 20 or 30, but Ghana we do. So it is 60 or 70, work overload. Now, if he meets that queue status, then you tell the person, oh, sorry, the doctor will not see people today because he has met his what? His quota. Do you understand? So that the doctor will not burn out and need to get sick and things like that. So technically, if this was the hospital management system in which we're doing the queuing like that, it means that this queue overflow, when the person comes to do it, we just tell them, oh, no more patients being admitted by this one doctor. You see, the way you would implement it in the real world is different. So the structure is there. And the reason why we learn it is we learn the structures so that you can implement the structures in different ways. I hope you understand me. Yes. Okay. So in going through, you have this, that. Oh, sorry. This one is supposed to be here. And then this bracket is not supposed to be here. Perfect. So we are telling you that you have done an overflow of your queue. Perfect. Then we will also tell you to return and stop doing anything in which you are doing before. But if the case is that, okay, sorry, here also has to be in capital letters. Perfect. Now, if the case is that the queue is not like that, the case happens that, oh, this individual here who is dealing with the queue, he hasn't met the threshold. He's not at the end of the queue. It is not overflowing. Then it means that at this stage of the code, we have to do something. If the front of the queue is equal to -1, then we are going to say the front of the queue should be equal to what? 0. Now, we are also going to say that if that is not the case, then we just continue. But if that is the case, then now we don't want the front to be -1, we want it to be what? 0. So that over here, we can just say the queue is equal to plus plus the rear, which is equal to the value we are adding. And then we would see out to the person that the value has been added to Q / N. The same explanation for here. It will be added, then displayed. Okay. Now, here we have done the enqueuing. So now let's do the dequeuing. So if someone comes to our queue and he's done doing what he has to do in the bank, we have to remove him. We are removing him from the front. So here I'm going to say enqueue is a function, so I have to give the modifier. Dequeue. So if the front of the queue It's just the same code here, so I just want to copy this one. I'll copy it here, but here I would say front rather. So if the front of the Q is equal to -1, then we'll tell you that there is nothing in the Q, so your Q is what? Empty. Now, if your Q is not empty, then we are going to say some few things. Oh, sorry. I have to check something else here. Or the front of the Q is equal to the rear of the Q. Then here, I don't think saying it is empty is good. We just say there is an underflow. That means there's not a lot of things there. Then we return. Over here, I'm just going to say C out Q front plus, and then I'll tell you we have removed from Q /n. This thing here shouldn't be here. It should be out of the if. What is it asking me here? Oh, sorry. Q. In here, I'm going to say if the front is greater than the rear, then the front is equal to the rear, which is equal to -1. Perfect. Finally, I have to do the display. So void display, so that whenever someone wants to know how many things are in the queue, they can know who and how many people are in the queue. Again, I'm going to say if the front of the queue is equal to -1, then obviously my queue is empty. And I must return. Now, if that is not the case, then I can say C out the queue elements I have to charge my piece. Okay. Did they come and fix the projector? Because today it is shining brown. The other time was very, very dark. So my queue elements are 4, and I being equal to the front, I being less than or equal to the rear, I plus. Of course, the moment we start doing things like this, it means your knowledge in loops and manipulation of loops and all of those things must be very, very hard. So this would be equal to I, and then over here, I'll do a small space here so that When the loop is done, I'll just tell it to go to a new line. And ladies and gentlemen, this is the code for the queue using simple functions to execute, whereby you can put items into your queue, you can enqueue, dequeue, display, and utilize how you want to utilize it. Again, I'll copy this code. I'll go and put it in your class group. The next topic we are going to treat today has to do with sorting algorithms. Oh, sorry. Sorting algorithms and implementation in C without classes. Now, sorting algorithms, I took the classes out because my students, if I go and bring classes in, even with the functions, I can see your face has changed. So if I go and bring the classes in, that one there, your face will change some more. Let's stay in just some full functions. Now, sorting algorithms are very important. Whenever you want to look for something, it is very important there is a certain order with it. Either they are in ascending order, descending order, so on and so forth. So that before I can find you, you must be in an order for me to be able to find you. If you enter, for example, if you enter a classroom and you are looking for a student with a particular ID, if all the students are seated in the sequence their ID is given, it is quite easy for you to discover where the student is, unless they are all scattered, then you don't know where you find the student. So before I can go and do searching and looking, for example, if you have your computer and you're looking for something and you type it into the search box, or you're looking for an item and you type it into something and you're looking for it, before you can do those things, there are sorting algorithms that you have to use to sort it out so that it is in a particular order. Then, based on that order, you go and look for what you are looking for. Now, the way we sort things are plenty. To be honest with you, a lot of people have come up with very, very marvelous sorting algorithms. Why? Because the faster I'm able to sort, the faster I'm able to find what I am looking for. Some sorting algorithms are very fast. Some sorting algorithms are very slow. Some sorting algorithms take too much computational power. Some sorting algorithms do not take too much computational power. Some sorting algorithms are not expensive. Some sorting algorithms are very expensive. So it is not in every situation that you would use the same sorting algorithm. Based on the time you have, based on the quantum of your data. Some sorting algorithms are good for a large amount of data. Some sorting algorithms are not good for a large amount of data. If you use it for a large amount of data, it will not work. It will not work. So the sorting algorithms we'll be looking at in our class is the bubble sort, the selection sort, the insertion sort, the merge sort, and then the quick sort. What is the bubble sort? Let's start with there. The bubble sort. So the bubble sort works by separately swapping adjacent elements if they are in the wrong order. The largest element bubbles to the end of the array with each part. Let's look at this very well. I'm saying that if I have an array, and there is a reason why we are doing these lists and sorting, and then we'll be doing searching and doing trees, because they all are derivatives of the what? The array. So if I have elements in an array and they are all scattered, they are scattered, you know. Let me see if I can have an example of this. So let's see. Bubble sort. Wonderful. This would be a great example for us. Good. So if I have this item I have over here, perfect. So I have items in an array. I have items like this, right? Bubble sort is saying that um, this and this, which one is bigger? The 5. So the 5 should come here and the 1 should go here. 5 and 4, which one is bigger? 5. So 5 should go here and then the 4 should come here. 5 and 2, which one is bigger? 2. So 2 should come here, 5 should go here. 5 and 8, which one is bigger? 8 is bigger. So 8 should remain there, 5 should come where? Here. That is my first pass. My second pass, I'll go and take the item which is number 1 now. So 1. Is 1 bigger than 4? No. So 1 remain. Now I'll go and take 4. Is 4 bigger than 2? Yes. So the 2 should come here, the 4 should come here. Is 4 bigger than 5? No. Is 5 bigger than 8? No. So now I have this. Then I'll start again from 1. Is 1 bigger than 2? No. Is 2 bigger than 4? No. Is 5 bigger than this? No. This bigger than this? No. So now I have what? Finish. So the bubble sort, you see that the name, you see that when you have water in a container and there are bubbles in the water, the bubbles bubble up to the top. So technically, I am just swapping to like get all the highest numbers on this side, and then I'll get all the lowest numbers on what? This side. Is that clear? Is that clear? Any confusion? Now, as you can see, it is a waste of time. Because even when we got over here, you realize the thing has been sorted out. But it doesn't know. It still has to go and check with the other figures to figure out what to do. Did you understand? So it's a bit of a waste of time. But let's read on. So I've explained the way in which it is achieved. Now, the time complexity, the best case, already sorted. It is 0n. Worst case, reverse sorted, it is n times 2. That means you have to do everything and then do everything again by the number in which you have. So if your number is 5, it's 5 raised to the power 2. That means you are technically doing 25. You're doing 25 turns to get your answer, which is a bit too much cumbersome. Now, does it use any extra memory? It doesn't use any extra memory because you see that what you have already, you are just checking, is this and this bigger, then you swap. Is this and this bigger, then you swap. Is this and this bigger, then you swap. You don't use any extra memory to create what you are doing. So it means the burdens on top of memory is very, very small. When do I use a bubble sort? When I have something, a small data set that I am going through, I would use a bubble sort. When the list of the item is almost already sorted out, I would use a bubble sort. And then I would also, when it is always sorted out, I would use a bubble sort. That is optimized bubble sort with a flag can work in 0n. So I would use a bubble sort if I fall under these categories. The selection sort. The selection sort is a concept of the sort that selects the smallest elements and moves it to the correct position. The process is repeated for each remaining element. Steps. Find the smallest element in the array and swap it with the first element. Find the second smallest and swap it with the second smallest. Then repeat until the array is sorted. So in this kind of a sort, what I am doing is that I am going to look through the entire array, find which one is the smallest. When I find it, I'll take it out and come and put it in the first one. And then put what was in the first one in the location of the smallest one in which I got. Then I'll go and look for the next smallest. Then I'll come and place it there. So I'm looking through the array and looking for the smallest, and then I'll keep on arranging them until I get the biggest in which I am looking for. So an example of that would be this image we have over here. Marvelous. So here I can see that the array I have here, one is the smallest. So I'll look through all of this one, discover one is the smallest, take one, put it in the first location, that is index 0, take whatever that is here and go and put it in the location of the what smallest. I'll look through again and find the second smallest, which is what? 2. Take 2, bring it here, take 7, go and put it here. Look for the next smallest, which is 3. Take 3, put it here, take 4, go and put it in the location in which I took the smallest from. The next one is 4. Take 4, put it here, take 7, put it here, and I have sorted out my array. So I'm not swapping like the bubble sort. I will go and select the smallest, come and put it in the location and continue doing that so my array is sorted out. When do I use a selection sort? I would use a selection sort when you need in place sorting and don't care about the speed, because obviously this sort is going to take a lot of time because I have to locate which one is smallest, move it, which means there is more computation being done, more algorithms being written to achieve the aims in which I am looking for. And I will use this when my data set is very, very small. Because if it's a large data set, imagine going to look through the entire data set, that is time 1. When you find a small one, going to swap it, that is time 2. Before you move to the next one, it takes a lot of time to do that. So this is not going to be optimal for the things in which you are going to do.